Okay, so welcome guys to our February 4th meeting. I'm glad all of you guys are here. So first of all, Autodesk Inventor. There's a couple options you guys can do to get this installed on your laptop or computer. First thing is to ask school IT to install it for you. If you ask the IT in the library, like during break or lunchtime, they should be able to install it to you in about 10 to 15 minutes. So if you have a little bit of time in the morning, during lunch, during break, this is something you can visit and they'll instantly download it for you. Two is student website. I'll guide through that at the end of this meeting so that people who have trouble can actually know what to do. And I hope this isn't too much of a demand, but I want you guys to have Autodesk ready by February 11th. Got it? So that's a week from now on. Everyone cool with that? Give me like a thumbs up. Okay. Remember, guys, it's Autodesk 2019, Autodesk Inventor, okay? Some people call it AutoCAD, CAD. It's the same thing. Autodesk Inventor 2019 Professional. Okay. So with that said, let me just go over this briefly, just so that you know. We're about to tackle some heavy stuff like heavy planning and a lot of heavy material. So this is just kind of like assuring you that whatever we're going to tackle, I'm going to make sure to help you guys and give you guys the support you guys need. So February 6th, we have an optional AutoCAD lecture. This is like me and a couple of guys trying to teach some of you guys how to use AutoCAD. Same with the 9th. And the 11th, we're going to start 3D modeling. In my calendar, that's one week from now on. So just have AutoCAD ready by then. Today, we're going to split groups, as in split roles, as in you're going to know what to exactly model, as in we're going to assign you what you need to do. And the 13th, we'll have an optional modeling help session where me and a couple group leaders will try to help you guys like, hey, what part are you tackling? Oh, why not try to do this? Or here's how to troubleshoot your issue. Same with the 16th. And 18th is the modeling checkup. Now, I don't want you guys to think that the 18th is our hard deadline for all 3D models. No, that's kind of like a soft deadline, as in, hey, is everything going right? Like, is there any like major problems that you need to get fixed? This is kind of like, hey, are you like halfway there yet? So everyone kind of understand the schedule. Okay. So with that said, would people actually like to have optional AutoCAD lectures and modeling help sessions? Like, do some of you guys like, so like, on a scale of 1 to 10, is there any one of you guys that are like, oh, I'm perfectly fine with 3D modeling programs. I've done it before. I can probably get used to it. Or is there like people who like, oh, I've never done 3D modeling before. Okay, so raise of hands who have never done actual 3D modeling softwares before. Okay, so, and I'll guess Seamus and Marvin's probably one of them. Or actually, I don't know. One of you guys maybe take engineering, but it's fine. I'll hold them anyways, just so that even if you know how to do AutoCAD and know how to CAD works, you can still stay in the meeting just to like get some help or get some info. Okay, so today's focus is finishing the design concept and role distribution. Now, finishing concept, this is the heavy stuff, the heavy workload today. Is actually finishing the design. It'd be great for us to meet in like a lab or like a classroom to actually discuss this physically. But since that's something we can't do, I've prepared a digital whiteboard. So tackling specificity of the wrist first. Okay. This is just some common labels. I'm sure Michael Cernius and Junso showed this last time to you guys for the specificity of the wrist group. Point A, obviously it's the circle pad where the specificity of the fingers design is going to go to. Point B is where it clamps down your hand so that the device doesn't like be loose or anything. And point C, just general gearboxing and overall structure, like the base. So as you guys can see over here, compartment A, the circle pad for the specificity of the wrist compartment. Point B, the compartment that holds the arm tightly. And point C, the overall box containing the gearbox. Okay. So everyone's pretty clear on what ABC does, right? It's fine if you have questions. Just let me know if you do have any right now. Everyone's pretty clear? Okay. So that's our very basic design. What we're going to try to go over today is actual designing, as in a little bit of drawing and a little bit of sketching. So can everyone see my whiteboard over here? Can everyone see it?
Yes.
Okay. So first of all, the shape of the overall base, point C. I'll have to retract you guys a little bit so that it doesn't take up too much space. Okay. So everyone see point A, B, and C over here. So for C, and I'm going to get this from Junso, is there a specific shape you decided for the base to be? Or are you guys fine with this general square or rectangle? Junso? Oh, I think his internet might have crashed. Okay, well, it's fine. Let's still go with the square. So we'll have the base over here. And anyone from the specificity of the wrist group, is there any one specific design Junso and Michael talked about for the wrist clamps? Anyone from the specificity of the wrist group? Here, let me try to look at what Michael sent me. Okay. Specificity of the wrist. Degrees of spinning can be switched per hand. Tightable arm brace. Okay, so tightable arm brace. That's good. So you guys will probably have the arm brace over here. Let me just draw a general shape of it. Okay, where is Junso? Okay, anyways. So we're probably going to have a tightable brace over there. And we're going to have a giant circle. Now, just as clarification, guys, we're not going to have the device in the dead center of the circle because it's going to be a little bit hard. Because as you see, if we do cut the point off here, the space left by your fingers is a little bit towards the upside, as in it's a little bit up. It's not, the space in your fingers aren't exactly in the middle, which means that specificity of the wrist group, whatever you're building, it's probably going to be over here. Now, the specificity of the wrist group kind of clear with why we need to place the specificity of the finger in the red box and not in the middle. Everyone pretty clear on this? Okay, this is going to be pretty important because this is your main mechanism. You know, as good as your tightener may be and your gearbox may be as solid as possible, if you can't bend the wrist, then you couldn't meet your objective. So let me just repeat it just one more time. When we cut off the wrist over here, the space between your fingers and your palm is not in the dead center. If we consider the point from here to here, it's a little bit towards the upside. So if we do have anything that stretches the finger over here, we need to make sure that it's lifted a little bit up. Because essentially, think of it like a Lego hand. It's going to be cut off from here through here. The space is way closer to the top than the bottom. Everyone clear on that? Give me a thumbs up. Okay. So with that said, that's the circle part. Okay, so that's point A. Now, for point B, raise of hands, who was in specificity of the wrist group? Lyndon, were you in specificity of the wrist?
Yes.
Okay, Lyndon, what did Michael talk about the clamping mechanism for point B?
I think it's only for holding holding this part of your hand firm,
Yeah.
so that it doesn't move.
Uh-huh.
And then I think that's it. We mostly like talk about the circle part.
Okay. So that's good. Maybe have like okay, so that's good. We can talk about this and we can try to design this a little bit better. So point B. So let's just say, what's a color I can pick for the skin? Okay, let's just do purple since it's a little bit easier to see. So let's say this is a cross section of your arm, as in, there's your bone and this is your arm standing like that. Obviously, we're going to have point B that's going to clamp down like that. Is that what you mean, Lyndon?
Yes.
Okay. Is there any ideas or any specific ideas on what to do for the clamps? Like maybe like a silicone material or maybe like, maybe latches. And specifically the finger group, you're free to jump in if you need to. Okay. Let's see. Okay, let me try to see what's up with Junso. I think he had to leave. But anyways. Okay, so let's probably assume that there's like silicone barriers over here. Let me get that in purple. Actually, let me get that in black. So let's assume we have like a silicone barrier over here and silicone barrier over here. Does everyone kind of agree that we should have something that like, covers an arm that's not just pure metal? Everyone kind of like agree with it?
Yeah.
Okay.
Yeah, because like pure metal is just going to be way uncomfortable.
Right.
I think you could have a full silicone sleeve too, so that way you don't have that kind of open section towards the top.
Okay.
The way it's oriented now.
Okay. That's a good point. It's just a safety measure, just in case a patient might have trouble sliding it in. It's probably not going to be that much of a concern, but actually, how about this? How about we have something that extends? So like, there's something you could do to like extend these two parts. Maybe like a simple latch can do the job. Maybe we can make this one piece like that. And then we can connect these 2 points and there's going to be a latch point over here. We can probably do something like that. Everyone kind of clear on what we need to do for point B? So very simple, point B. All you have to do, let me just draw a little bit more of a precise drawing over here. All you have to do is have a flat surface. Think of it as like there's a human arm over here. And you have to create maybe a design like this, or maybe it's a simple block like this, and make it so that this maybe could be adjustable. But again, we can probably handle very minute details like that next time. Everyone get what point B needs to do? Okay, so I know we don't have everyone here. I know this week's very busy with like the whole sports team and everything. But from people in the Specificity, the risk team, is there anyone who wants to tackle on compartment B?
I think I'll do it.
Okay, that's perfect. Let me write down your name quick. Okay. So I'm gonna post this video anyways on the YouTube channel, but if Lyndon, feel free to take a screenshot or anything, but I'm sure you get the general gist of ideas. Okay. So with that said, Lyndon, can I erase this diagram over here?
Yes.
Okay. So with that said, we're kind of clear on what B needs to be. It's a clamp. Now, for A, let's actually combine A and B together, since I feel like it's probably going to be a little bit more of a simpler design. So for A, all you probably have to do is create a solid base and then actually create, a little bit of tinkering with gearboxes. So let's just say this is something you see from the left. There's your circular base, and there's your guards that Lyndon is doing, point B. And this is point A, and this is point C. So point A and C, what you have to do is make this really thick cylinder that's really thick but also short. I'll go a little bit underground, have some very simple gearbox over here, maybe something like this, like that, or maybe something like this, and they have a knob over here. So something very simple like this. Do you guys kind of get the general gist of idea of what you guys need to do? All you have to do is have a very simple motor, a gearbox over here, a rotating platform, and a switch or something you can twist. I don't know what they're called, valves? Like a valve you can actually use to bend your wrist. Is there anyone in the specific wrist group that wants to take point A and C? Okay, what group was J-Ho in? Let me see.
I was in finger, I think. One with the cylinder.
Uh-huh. Okay. Let's see. Yeah, let me grab my list quickly. It's a little bit hard since not everyone is here, but it's fine. It's something the group leaders will automatically assign anyways. So let's see, Julian, Luca. Oh, I know Julian's busy. Okay, Lyndon, you took that. Gabriel Jonker. Jonathan Lamb, are you here today? Okay, that's fine. Alex, you there?
I am.
Okay, I know you're new to this. Do you kind of understand what A and C is doing?
I believe I do.
Okay, well, I won't
I think I
assign
have
it
an
to your
understanding
right.
of the part.
What was that?
I believe I have an understanding of the part.
Okay. I'll leave this not at it, it's fine if you don't want to do it, but then when you do have people that are working with you, at least give them like a solid idea. Do you want to take like a screenshot of this later?
Yeah, sure, I will.
Okay. Looks like Junso's electricity went out. Okay, well, that's fine. For specifically the wrist, guys, don't worry too much about 3D modeling. Generally, for you guys, it's going to be a little bit easier than specifically the fingers, which is kind of like the really rigorous hard part where you have to focus on the minute details of everything. So don't feel too overwhelmed. The specific wrist, yeah, it's a bigger design, but then it's going to be way simpler. So Alex, you got like a picture of this?
I do.
Okay. Okay, so that's good. We'll have a general gist of, we have some people who know the general gist of what we're going to do. So now let me share my slides back again. Okay, so we got the specificity of the wrist compartment done. A and C, that's going to go with Alex, Foy, and a couple other people that are going to get assigned in the future. And component B, Lyndon. Lyndon, if you want to work with other people in your group, that's perfectly fine. And if you have any trouble with actually modeling this, just let me know or come to the help CAT Autodesk help sessions. So, you can get some help for them there.
Okay.
Okay. This is probably going to be the hardest part of our meeting, specifically the fingers. It's definitely great that a lot of the fingers group is here. I know Ethan, you're for sure here. That's good. Okay, so specifically the fingers, I'm sure Jake and Ethan showed you guys this thing. And I know a lot of you guys are saying, what the heck is this? This looks really weird. I don't know what it does. It's fine. Specificity of the fingers is definitely more complex. So before I move on to actually designing and drawing, let me explain this just one more time for you guys so that you guys have a general understanding of what mechanism we're using to facilitate motion. So do you guys see these two little red pins over there? That shows the actual motion. Like these two flaps are actually going to move. That's the point of movement. That's like the center. Now, the reason why I color coded this is to make it understand a little bit easier. The patient, think of it like a Lego hand. You know how like a Lego hand has like only 2 fingers technically? Think of it like that. They just shove it in the section and they grasp onto the blue part. So the fingers touch the blue part. Everyone kind of understand that idea? Like how it sits in there? Okay. And then the pins are going to rotate. So these pins are going to rotate that so that it actually opens it up and it closes it up. And you're asking, well, I see how it opens it up, but how does it close? Well, that's a great question. That's why we have compartment B, where it actually covers your fingers. So it has full control of your finger. It's kind of like a glove. It's like a glove with many holes that automatically moves for you. Now, before I move on to precise planning, does anyone have any questions with this? It's fine if you do. It's a very intricate design. Anyone have any questions or they get like a general understanding?
So compartment B is also a mobile part?
Yeah, compartment A and B moves.
Okay.
And compartment C is just like a circly thing that, that's the base, basically.
Okay.
Okay, so looks like everyone understood that. That's good. Thank you to the group leaders for hard work explaining that. It's definitely a complex model, but I'm sure it's for sure going to work. So don't worry about that, guys. So with that, let's go over some precise planning. So I know last time, Ethan, are you still with us? Okay. So last time, Ethan, you discussed this with your group. One of the main concern was the entire shape, like, because guys, let's think about it. If you're holding a cylinder, like this water bottle over here, if you're just holding a cylinder, it's going to be a little bit more uncomfortable, right? So one of the things I think Ethan suggested was having a teardrop. So, and you guys might be thinking, well, okay, well, how does a teardrop help with any of this? Well, if you guys think about how your hand grasps onto things, if we have a shape of something like this. Let me try to draw that one more time. So if we have a base like this and a base like that, and it's kind of like a little bit elongated, and let me try to make this part a little bit more elongated too. Okay, so you see how this type of shape will be a little bit easier for you to hold than a regular rough cylinder. You guys kind of get the idea? It won't be exactly like this. As you guys said, it's most likely going to be a teardrop. So it's most likely going to look something like this. Now, and then you might be asking, hold on a minute, there's semicircles. How do we go on to teardrops? Well, that's a good question. One of the things that also emerged in the discussion you guys had with the whole specificity of the fingers was actually having solid shapes rather than actual semicircles, because they might also be a little bit more weak. So what we can do is, let me try to draw my best. So let me just draw a regular cylinder. And of course, the shape is going to be a teardrop, not a cylinder, but this is just for the sake of explaining. Let's say we have a cylinder over here. One of the things you guys suggested was, actually, what if we just cut this in half and then make these two open up and close? I think that's what Jake suggested. And with that, it can be a little bit more easier for us and our mentors to create this whole mechanism, because all we have to do is maybe 3D print a regular object and just cut it in half. You guys kind of see the logic behind this? Everyone kind of give me like a thumbs up. Okay, so if we have a solid shape And of course, there's going to be the whole, the ones that like trap your fingers in, like that. If we just have a solid shape, we can also switch it out with different shapes, which is something I think Ethan mentioned last meeting, where, if it's a little bit easier for us to make these parts, we can maybe switch up these parts depending on the actual patient and who's gonna like use it, basically, so that when we do donate to like a medical center, we can tell them like how this works and how they can easily just use a 3D printer to like come up with a better shape if they do find one for that specific patient. Now, people said for this shape, a teardrop, which is a great idea. Now, the hard part is actually CADing it, which is why I want to separate this into as many parts as possible so that one person does not always have the hard part. So I'm just going to say, let's face it from the beginning, as in like, let's face it from the front. Let's say we have a cylinder like this, and then it splits open like that. Now, because we voted on a teardrop, what we can try to do is make the base a little bit more solid and then change the shape like this. And then we can, this would be one part, and that would be other part. Everyone kind of get the gist of what we're doing for the basic shape. Now, the basic shape, you guys suggested a teardrop, but if you do want to try another shape, that's totally fine too. CADing this, what I can recommend, don't try to get a complex shape. What you can do easily in CAD is just make like a cylinder and then a little bit like, kind of like attach them like this. That's all you have to do. And then you can use something, excuse me. And then you do something called beveling, which is it rounds up the edges. So that's a very easy alternative. So I know when you look at Autodesk Inventor, you might be asking, how do I actually draw these curvature models? You don't really have to. So with that said, let's make that component A, this basic shape. Think of it as like a vase, like where they put flowers inside. Think of it like a vase, but then it's like really shrunk, and you fill up the vase with like cement or something to like make it concrete, and you just cut it in half. Now, specificity of the fingers group, does everyone understand that? This is a pretty important logic. Everyone understand it? Jeho, you think you kind of get like idea of it? Okay. Now, this is compartment A. Who wants to take charge of CADing this part? Anyone from the specificity of the fingers group?
So for that part, we're just trying to CAD like the teardrop shape.
Yeah, that's all you do.
I'll try that.
Okay. Okay, so with that said, that's one part. And now what we need to focus on is how do we close our fingers? Well, let me just do this in green so you guys can see a little bit better. What we're gonna do is have individual guards or something like covers for your fingers. So what we'll have is for each shape, because this is separated into two. Let me try to make that a little bit more clear by drawing into purple. So everyone know this isn't just one shape, but it's one shape cut into two. Now, with that said, we're gonna have like finger guards that kind of like mimic the shape. And let me change up the thickness so you guys can see a little bit better. Kind of like that. And we're all seeing this from the front. So, this isn't like a side picture or anything. And we're probably gonna have silicone pads over here, silicone pads over here, and silicone pads over here. So that when you do wear this like mechanical glove that's really oddly shaped, you feel at least a little bit comfortable. Do you guys kind of get the gist of what I'm saying here, or is this not making any sense? Everyone kind of getting the sense? Okay. And if you guys see this in like a top-down model, since this is going to be a circle, this is where you would place your hand. Let's think of like a Lego guy. Let's say this is your Lego hand and you put it in like this. The green covers, they're probably going to be something like that. Everyone kind of understand what I'm saying? That's what covers your hand from here to here. So it's like pad over here, pad over here, pad over here, and one pad over here. Everyone kind of understand what I'm trying to say? Okay. So with that said, who would like to take this part? This part's going to be a little bit hard because there's a lot of intricate shapes, but don't worry much about it. We'll try to help you guys. Is there anyone who wants to take on this part? I was going to originally make it so that Jake takes it, but if there's anyone else who wants to do it, just let me know. And don't worry, for all of you guys, there's also something else you guys need to do anyways. So this is just kind of like additional work, I guess I should say. And you want to take it? It's fine if you don't have to. It's a really intricate, complex shape, but you could definitely contribute a lot to the club if you do. No one wants to do it? Jaeho, you think you might want to do this?
Well, since I don't know how to work with CAD, well, I did work with like 3D printer designers before.
Oh, no, don't worry about that part. We're not going to start CADing until like next week. This is just kind of like, do you have interest in it? Because we'll make sure that by that time we start, you'll know everything you need to do.
Okay, then yeah, I'll try.
Okay. And if you ever feel like overburdened or you don't know what to do, you can always ask Jake to, put like the finishing touches or help you, send him like a file and he can, try to see what's wrong with it. Okay, so Ethan, Fingers, and Jaeho, you'll take. Oh, and for reference, this is B, by the way. Jaeho will take B, and Ethan, you'll take A. And of course, C is just, a cylindrical base. It's very easy. You don't have to worry about that part. Okay, so now that we have our general role or know what to do, let me just give you a reminder that don't feel afraid or don't feel nervous to try out these models. We're going to try to make sure that everyone contributes to these models anyways, so you don't have to work on everything by yourself. But by the 11th, don't worry, guys. I'll make sure that every one of you guys is prepared for AutoCAD. And if you guys still want to, feel like you want to try AutoCAD a little bit earlier, you can always look up videos, Autodesk Professional intros. And you don't have to learn specifically about like constraints or 3D projections. All you have to do is just make a basic model. Remember, guys, let me be very clear. We're not going to 3D print your models. I mean, we could if we wanted to like show off to, our school what we're doing, but then we're not going to actually print them to use for medical use. This is like a very basic 3D model to show our mentor and our, I guess I should say, helpers understand what we're doing so that when we come to building, they can help us a little bit more effectively. So think of this model as like a reference picture of our end goal. Everyone kind of get that? Don't feel like nervous as in like, oh shoot, like, do I have to like model everything perfectly? Hey, it's giving me like a constraint error. Like, what do I do? Don't worry about none of that stuff. All of this is just a very good reference picture for other people to see and for our club to see as well. Because if we do have a good reference picture, I'm sure everything will be easier on our actual designing stages and building stages. So it looks like everyone's clear with that. Let me move on. Oh, and very importantly, multiple people can sign up for one model, or you can work with their peers to model either A, B, or C. Just know that, if you're Lyndon, Alex, Jaeho, Ethan, Jake, Michael, and Junso will always try to help you guys. And people who aren't involved, like Robert or maybe Robert or like Seamus or Marvin, and you want to try to get in on the whole designing process, you can always contact one of these people and say, hey, is there like any specific part you need help in? And then Lyndon could be like, yeah, actually, I don't know how I didn't actually CAD the silicone pads. Can you like CAD me like a very solid silicone pad and send it to me? And Robert could be like, sure, I'll do that in like something minutes, and they'll send it, and Lyndon can use Robert's silicone pad models. So just know that it's perfectly fine for you guys to cooperate. Remember that the deadline is not set yet. There's no hard deadline. So feel free to take your time. We're not going to force this on you. I know this looks like a lot of stuff to do in the beginning, but don't worry. We're going to do this step by step. This is like a general overview so that you guys know what the end goal is going to be. Got it? Good? Okay. So with that said, now that everyone knows what they're doing, let me go over some deadlines again. AutoCAD optional lectures. If you guys want to attend that lecture, please do. And for people who didn't take a specific part, everyone except Lyndon, Alex, and Ethan. And of course, Jeho too. I'm still going to encourage you guys to at least model some parts, because as you guys see over here, this is like the very like backbone of our design. But there's still little things you still have to CAD, like a pin or maybe like a gear or maybe like a turning knob that you still have to CAD anyways. Those things are going to be undertaken by people who didn't sign up for a major model. Now, if you're thinking, well, actually, now that you say that, I do want to work on a major model, that's perfectly fine. Just Discord me. I know not a lot of people showed up to this meeting. I know a lot of you guys are busy, but still thank you guys for showing up. I'm probably going to do a similar lecture like this soon. So at that time, when we're talking about role distribution again, if you would like to sign up to be one of the modelers for the major backbone, you're still fine to tell me that. So with that, February 11, start of 3D modeling. Please have AutoCAD by then, but don't worry, we're going to go over something at the end of this meeting. Optional modeling help. Now, Lyndon and here, yeah, Lyndon, Foy, and Jeho. Let's say we start modeling by February 11th, and then you still run into trouble, like, hey, I'm having trouble with this. Don't worry. Excuse me. You can still come in at 13th or 16th. Now, this is just an optional meeting time. So if you call me like any week of the day and I'm available to answer you, I'll make sure to answer you and help you on the way. But this is just kind of like a time set where I'm just going to sit there for like an hour and help people with modeling and CADing. So everyone kind of clear with what these dates are for. I wrote optional there, but then I highly encourage you guys to come down so you can learn more about CAD, because, you know, remember guys, you signed up for this club so that you can get experience with how to design like medical devices, and, you know, what steps are taken for medical devices and what's like a designing process. This is like a crucial part of it. So everyone who wants to experience part of that, I highly encourage it. And you know what, for people who don't have roles yet or don't have a specific role yet, but which I'm going to send you guys roles anyways within a week or two. But then for people who are thinking, wait a minute, now that I kind of got used with AutoCAD, I want to like actually take on a major part. Well, if you come to these optional meetings, and if there's me or any of the group leaders there, we can always mark your name down. So know that nothing's set in stone. You can opt out or opt in anytime you want. And of course, 18th. I really want to stress this. The 18th isn't a hard deadline. It's just a soft deadline for like, hey, is everything going well, or is there like any major issues that are occurring? That's all it is. It's kind of like a checkup. Everyone got it? Give me like a thumbs up. Okay, that's good. Okay, now this is around the end of the meeting, so I'm going to go over how to get Autodesk Inventor on your personal computer. Now, if you do already have Autodesk, you're free to leave, but I'm just going to show this anyway so that, maybe you guys won't have to go through the trouble of doing it later. So let's see, AutoCAD, Autodesk Inventor Student. Okay, everyone see my screen, my Chrome tab? Okay, I'm just gonna walk through you guys how to actually, let me actually do it in another Chrome tabs because this one's already signed up. Okay, you guys see my gray Chrome tab now? Okay, so let's go Autodesk. Okay, so all you have to do in Google is type in Autodesk Inventor Student and click on the very first link, okay? Anything with student in it. Autodesk Student Community, Student Education Software, Autodesk Fusion 360, free student download. Let's go with www.autodesk.com/education. If you want me to post this in Discord, I will. But then after you go into this page, what you have to do is click on Get Started. Everyone see the Get Started sign over here? All you have to do is click on that, and it's going to take you a series of, where are you from, where are you this, where are you that. Oh, looks like someone's chatting. Okay, thank you, Jo. But yeah, click on this and create an account, and don't do it with your school account. It's fine if you did it with your school account, but it's better if you do it with your personal. It just makes things a little bit easier. But then let's say you do it with your personal email, and then, oh, one very important thing. It's going to send you an email or a notification that you have to send in picture proof of you being a student. Now, this is very automated. It's not something you have to wait. All you have to do is take a picture of your student ID and send it. And that's all you have to do. Everyone kind of clear on that? All you have to do is send a student ID. No, nothing else. It says oh, you got to put a school transcript or something. No, just put a student ID. That all works 100%. So after you do that, Ethan, this is where your problem came up. You're like, okay, there's a bunch of softwares here. Which one do I choose? Well, what you want to click is Inventor Professional. You guys see this? Okay. Now, let me go to my actual email account so that you guys can see what it's like. So I go over here, autodesk.com, student education. I personally have an account myself, so it's fine. So let me sign in. Oh, and you want to click on this blue button that says Get Started. When you do click on it after creating an account and getting an email notification that says, congratulations, you're now approved for student services, all you have to do is click on Get Started and get Autodesk Inventor 2019, okay? This is very important. I don't want anyone getting messed up. 2019. Everyone clear on that? It's not any other version, it's 2019. It's because that's what the school installs it for you. Now, you can do this yourself on your personal computer, but if you want to just get it on your school computer, you can just ask IT, like I said. Everyone clear on that? I already posted the links in Discord, but if you have any trouble with getting Autodesk Inventor, even downloading it, just let me know, just Discord me. Got it? Okay. So with that said, that's the end of our meeting. Thank you very much for coming. I know not a lot of you guys could come to this meeting since this is a very busy week with the start of third semester, but don't worry. I'm probably going to hold a re-meeting or share this video to some people so that, if you did miss this meeting, you can always just revisit the video. So with that said, thank you very much for coming. I know most of you guys know what to do. Try to get Autodesk Inventor by 11th and watch a YouTube video, an intro to Autodesk for 5 minutes or so. But with that said, you guys are free to go. Thank you very much.